test. But this is something, so I mean, I got to know all this. And then
all without a calculator.
Yeah, and then my weakness, this is my weakness right here. I know this is my weakness. I just need to steps. I just need to know the steps.
Okay. So what you're saying is you want the in-between. You want to understand.
Yeah, I want to understand.
Okay, you want to understand it. Okay, that's good. Okay.
Really good at figuring out either 1% or 10%. And using that knowledge to build all your other percentages. So think of either the circle as being the whole thing, and then I try to think how the pieces are broken up. Another good thing to think about, think of a grid with 100 little squares in it. And that would be, are you going to be here next Monday?
Yeah, I'll be here.
Okay, because we should look at that grid together, because a lot of my students really like that grid. It helps them understand percentages.
She showed last time it was dealing with shapes, and he said a dimensional.
Here.
He said it,
Well, just like, give me a rough idea. Like a box?
Yeah, but it was dimension. I can't. It was dimension when you add on.
Was it for a volume? Was it for the inside?
That's not dimension.
Well, don't worry. So then what did you have to do?
The square sandbox. How many bags of sand can you fit in a square?
So was it kind of
sandbox?
Was it kind of like this?
Yeah, that's the dimension. The dimension of a.
So it's kind of like this.
Well, she drew a dimension of this is the dimension of a cube.
Ah.
A cube dimension.
Yeah.
And the cube, and it was, she said the cube dimension. It said
well, give me some. Let's get some numbers. Let's just throw numbers on it. Go ahead.
She said it was one. It's all around, but it was one. Each side equal up.
Okay.
Each side was one, so we know it's one cubic inch. Yeah, one cubic inch into a square box. How many can you? So it wasn't how many bags, but she did. She took. I didn't know she took. She put the cubes, and it was 5. It was 5, 10, 15, 20, 25. Because the answer was 25 bags, but that's how many we could fit. And the cube, but she took each cube was
like a 1 by 1 by 1 by 1.
It was 5 each. No, not each cube, but the 5 cubes
represented one bag.
5, because I'm assuming this is since this is one each. One, another cube is one. If you add them up, it's 5.
Right, 5
10,
cubic
15,
inches.
20, 25. 5, 10, 15, 20, 25. And I guess that's how she came. Well, that's how she came up with the bags. 25 bags can fit in there.
Well, because you're probably learning about volume. So the idea of volume is you're asking yourself how many cubic dimensions. So let's say you're measuring this in inches, and it's 5 inches high. It's 15 inches long.
Yeah, they said it was a.
And then maybe this way it's 10 inches, right? And they're saying how many of these cubes that look like this could fill it up. And so there's a formula that you can use, but you're basically figuring out, okay, if I want to figure out how many in the bottom row, if I go up one, it's going to be 15, it's going to be 10 across this way, 15 back that way, that's 10 times 15 in one row, right? It's got to go 10 across, because it's 10 inches, so I'm going to be able to fit 10 across this way, 15 back. 10 by 15 gives me 150 of those cubes. And then they're 1 inch high, but I need 5. I'm going to go 5 stacks. So then I go times 5, right? And that's like, whatever that is, 70. I think that's right, 750. So I can fit in 750 of those cubes into that box. So that's what volume is. It's saying how many cubes.
I need one of them. I need one of them.
But I have this, but here's what what I'll bring you next week is we'll look at isometric dot paper where we'll play around with sketching these shapes so that you can really get a visual picture of how those cubes, because if you've never messed with volume or built with cubes, it doesn't make as much sense. And we actually have some centimeter cubes, so you could actually kind of build yourself a box to kind of get a sense of what it all means. But the idea of the the idea with the sand is it'll say this is so many cubic feet. And so if you know the dimensions of your box, you know that when you dump in that first bag, it'll cover, like it'll get so high, and then when you add the second bag and so on. But I remember having to do that with mulch. Like they made suggestions about in a garden, like if you want to put so many bags of mulch and make it so deep, how many bags of mulch do you need? So this idea of volume comes into play in landscaping a lot.
So that's people with gardens.
Yeah, right, exactly.
Or front yards.
And then think about the next time you look at your can of pop. It talks. That's what they're talking about. The volume of the pop. How much pop fills that can? That's your volume. They'll talk about liters and that kind of thing. Yeah.
Because I'm learning meters. Meters is. They say meter. I got it. Meters. I just put stretch.
Well, yeah, but when have you ever heard people talk about meters, like 100-meter dashes?
Like football. I say
right.
Football.
Right.
Meters that, and then liter, I just thought of pop.
That's right. That's right.
Say liquid.
That's right.
Volume.
Exactly. There it is. That's
the last
exactly
one was mass, which was. I mean, not mass.
No, you're
grams.
Right. But that is mass.
So basically, weight.
Yeah, that's right.
I'm trying to think of something that can weight.
Yeah. Sometimes you'll see grams on boxes of like cereal and stuff. They'll talk about how many grams of carbohydrates and things like that. So you can think of that as mass. So that's really good that you came up with those things. But that's how the idea of a 100-meter dash. Think of it as a length. So it's the distance.
We times the
length,
the length times the
width, height
times the. Well, then we got the answer. Then we times the answer by the.
Right. So the formula is length times width times height, but it helps to understand kind of where that formula comes from. And I think of it as, if you think about it, as building layers of these cubes. So if you know that it's 10 inches this way and 15 inches that way, you know that it's going to take. You're going to have 15 rows of 10. Right, cubes along the bottom, and then you're going to make them 5 stacks high. So, have you ever seen cans of pop stacked in the store? Like where they'll have the 6 packs and they stack them up.
Yeah.
Yeah, that's the idea. You could figure out how many cans of pop there are. You figure out you got 12 cans this way, 6 cans that way, and there's 10 stacks. Yeah, the length and that's exactly. And that would figure out how many cans of pop there were.
So you know how much. So you know what you're shipping.
That's right. See, exactly right. That's exactly right. So think of the volume that way. Obviously, in the sandbox, there's no gaps between cans. So it's a different thing, but it's that same idea. You're thinking of building those layers, and that's your volume.
This can be the same for like skyscrapers or like a building or something.
Exactly. Oh yeah. Think of the floors.
She was telling me about. We was talking about shapes. What was it?
Parallelogram.
Yeah, parallelogram. Parallel. She was saying each side, certain sides. Were the same.
Yes.
But a rectangle is going to be equal. Everything is equal on each side.
Right.
It's a parallelogram. And I told her, well, can you just... Actually, I said, can you... What did I say? But it was something I just wanted to, like... So I get the concept of it.
Right.
Because at first I wasn't seeing, she was like, well, this is the same as this. I'm like, well, no, because it's pushed over.
Yeah.
She was like, she showed me, but the way she showed me.
See, I love that, though, because you're absolutely right about that because of the angles. But what she was saying is that the lengths are the same, so you could tip them up and they'd still be the same size. Yeah, is that what she was trying to get you to
that's
see?
just trying to get me to see, but I just couldn't see it because it was pushed aside.
Yeah, exactly.
She was like, this is like that's his.
So if this was 12,
like this is equal to.
So if this was 12, what would that one be? Oh, I see what you're saying. Now I got what you're saying.
Like she was saying, like this.
Yes.
Same as a regular.
Right.
Only thing is this pushed over.
It's tipped over. It's the angles.
Yeah.
Like this angle here is not 90 degrees, and here it is.
Yeah.
So it's as if it tipped over. You're right, but it's so they're kind of in the same family. So the opposite sides are congruent, meaning the same size. Opposite sides are congruent. And that's helpful to know in something like this, because if this is 10 inches here, and this is a box, this is also 10 inches. And this is also 10 inches.
Or say we had a, say, what was the sandbox? The square sandbox. What if it was parallel?
A parallelogram sandbox? Oh my goodness, I have to think about that.
So with the numbers, so would it still be
Yes.
with the height and everything still
But it
be
would
there?
be trickier to find the volume because, well, let's see. If it was a parallelogram sandbox, well, I wish I could.
She was telling me about that.
I wish I could draw the picture, but if you think about it, if you were to take, well, let's think about this. If we were to take this and simply just shift the sides, would the space inside be the same or different? I want you to think about that. When I come back on Monday, we're going to talk about it. I want you to think about that. Think about whether that would change the space inside or not.
We're gonna think.
Like if it was, so if we had it like this, would it make a difference if we simply tipped the two sides? If we just made it so it went more like that instead of that. So we got to ask ourselves, would it take, is the space inside going to be the same?
So I mean, so you saying so you're asking are the angles the same?
No, I'm asking like, would the amount of sand that would fit inside this sandbox be the same if all we did, if all the numbers were the same, we just took the box and tipped it so the corners were not square. Like if we decided to just to make it look more like that.
So I wonder would it be so I wonder what the cubes would it well obviously well even if it didn't then the cubes
the number of bacteria would be like 2.
yeah, if it didn't well obviously one of the cubes or some of the cubes is going to be left out. So 1, 2, 3 and then say we get to the last one and then say it don't fit in there all the way. So that means
They split off twice as often.
You're going to have to maybe cut the cube or something and figure out how to wedge it in there.
Or are we just is this cube? Are we gonna have to stretch? Are we gonna have to stretch the cube? Are we gonna have to add just a little bit more onto the cube? So that means the cube. So that means one of the entire cubes might be more than 1 cubic inch.
Well, then I think we're gonna have to think about that and play around with it next time. I love that. I love it because you're absolutely right. Because if that's not a square angle there, you're not going to easily place those cubes in there. So the question is, something's not going to fit. So what does that mean about the volume? Does it mean it changes, or does it mean it just looks different? Like if you take this cube and you chop it up in pieces and shove it in there, and you just use that, and you could end up having the same amount of total cubes. They just don't look the same.
Now I'm trying to think. Yeah, now I'm trying to think of instead of the cubes, so the sand. Because that's what it really is asking, the sand.
About the sand. And sand.
So is the sand going to fill up?
The same way, because the sand can go in any. The sand can fill up any corner. See, now you're thinking. I got you thinking. What a great question. That was awesome. I've never had anybody ask me that question before. But now I'm gonna have to bring in some sand.
Or because the sand is going to be. It's going to be more. I think it's going to be more. I think it's going to be more sand because I think it's going to take. Well, or. No, it's going to be less sand because, hold on.
But I like you thinking about the sand instead of the cubes.
Oh, it's taken away from the cubes.
Wait, that one in?
Wait, you want to
All the other ones that don't have it? How much sand put in there? Is that sand on the sand?
Right.
Is it more sand?
Same sand, more sand, less sand, or so that
More sand for that area.
right,
But
right.
we thinking of this as a whole. So we can't just think of the sand as just going over there because it's going to be
Right.
because we're thinking of this as a whole.
That's right. And
so it's
the
sand
other thing is to just consider these two things here, because pretend these are this. I mean, we drew them and just drew them, but I want you to think about, because I want to go home and think about this. If I take this rectangle, like you suggested, and we just tip it, is that area inside going to be the same? Or am I changing the area? Because would you agree that that if we take the sandbox and all we do is shift it, the height of the sandbox is going to stay the same? Would you agree with that? If we take the sandbox, it's on the floor, we're just going to tip it, is the height of the sandbox basically staying the same? You keeping
It
that?
has to be green.
If it's a 5-inch board, is it still a 5-inch board even if we tip it? Even if we turn it a little bit? Well, you have
That's
to,
a good question, but because I'm trying to look at the front, the height. I mean, what the length part.
okay, the length and width,
You said this is the
but is it still
sand.
gonna, but is it still gonna be 5 inches high? Even if we take the boards and go like this way? Are the boards still 5-inch boards? 5 inches high?
We got to determine: are you moving the box? Are you moving it with the sand already in it, or the sand is not in it?
Let's say we don't have the sand in it. We haven't put any sand in yet. We decided to change our sandbox.
We wouldn't know unless I don't think we wouldn't know unless we tried. And then, but in order to try though, we got to solve it
Right.
before we put the sand in it.
Got it. And then that's going to be our challenge, is to think, how can we figure out the volume of this? Yeah, I think, yeah. All right, good. We got
Back anything anymore.
All right. And what is your first name? Jarrell. I'm Cheryl. All right, we have a plan for next week, Jarrell. I'm excited.